So, so let us now try to understand, so now we have this, right? We know, we understand what is data engineering and ML world, but now let us understand how do we have to see the data, right? There are different ways of seeing the data. We'll see how generally data scientists, they see the data. Data scientists view the data. Okay, so there are many ways. We shall touch upon a couple of ways. So let us assume you have two data sets. Okay, so generally as a data, so now that you're thinking about the data, what can be the data types? So let us broadly try to understand. We'll not go deeper into it, but let us try to broadly understand. So you're going to deal with number. Do you all agree? Yeah, you're going to deal with text. You're going to deal with image. You're going to deal with voice. You're going to deal with video, right? Yeah, and I'll slowly add a few things to it. In the number, you have continuous and discrete. Yeah, so and then you will have a category as in, something like male, female. Yeah, and that kind of distinct values, right? You will have some set of values. Yeah, you'll always choose like class 1, 1, 2, 3, like that. Yeah, so that kind of data. So this is what typically you will see, right? Data is always seen like this. Now what can you do with these data? So we'll take one example. As we proceed, we will talk on all these type of datas. Okay, these are the data types. Yeah, so in the programming languages, you might have seen a different data types. I mean, these are broadly classified. If we go deeper into it, you will see the same thing: integer, float, boolean, like that, right? But this is a much advanced type of data, right? This is what generally the world, all your social media platforms, you would see these kind of data. So let us assume that you have two data sets. Okay, just for the sake of this discussion, let us assume you have two types of data. So this is data set A, this is data set B, and both are of type number. Okay, and they are similar. For somewhat, these data are similar. They both are similar data, because let us assume, let's take an example. They both belong to a certain set of employees, and here also this is another set. It belongs to a certain set of employees, and you're trying to do something on this data. So now, generally, what, whenever you want to draw any insight, let us take an example that you want to draw this employees who have joined in the month of October, employees who have joined in the month of December. Okay, these are two data sets. So, and you want to see you want to draw some conclusions, average average number of men versus women. Okay, one type of conclusion. Yeah, and then their age group, another insight, right? So you want to draw certain insight. These are simple insights. So what would you generally do? How would you see the data? So generally, anything, in a data world, you want to see some sort of prediction, right? Or want to some sort of insight on the data. You would always average it out, right? So when you average out the data, yeah, so when you average out the data, what is it called? Generally, in a statistics word, this is called as a mean. Do we all agree? Yeah. So, but what we are not going into the theory of mean, mode, and median, but what feel we want to get is, how do we see the data? So if I am averaging out the data, So the basic thing is, so I have some data, and that data is actually taking a certain shape. What do we really mean? Okay, so they generally your y-axis takes up the frequency, the count, right? And generally this is your spread. We call it as your x-axis is always that whatever, right? So let us assume it is a age is your x-axis and frequency. So anything of this sort, right? So employees who have joined in the month of October, and then you see this peak, right? You see this peak. What does this indicate? Mean as an insight, it will always gives you what is collated here, and you are actually interested in this. As a data viewer or as a data scientist, you would want all your data to be towards mean. So let us assume you you wanted to hire the freshers, okay, and you really do not want people with a very less age. You wanted some minimal age. So this, let us assume this is your 16 age, and this is your 30 age, right? So what is the spread? What is the range here? 16 minus 30, it's 14, right? This is your upper bound, this is the lower bound, 14. So in between, how much it is? This will be 16 plus 7 I have to do. Okay, this is around 23, right? Your median on that. So as a data scientist, you would prefer to have all this. Helps your prediction. If at all your values are actually collated here in this region, right? The more and more people are into this region, they are closer to your mean, gives you a strong insight that your data is actually is taking what, taking that central value. So hence that is why it is called a central tendency, right? It's a central. You want a measure of it. Or let me give another example. You're looking for an house, you want to take an house for rent, and you're going and looking at the data, what it is. So for you to make a decision where to buy, if you have a data like this, okay, this is your mean, and this data is not spread so much, so it is all very near to your mean. So this is giving you a good indication that it helps you to take the decision. Yeah, the more data which is closer to the mean, median, mode, right? That so the point we are trying to make is, from we were talking about the data perspective, right? The more the data is more closer and collated, it doesn't apply always, but for the data where you could actually calculate such an insight, right? Yeah, this perspective always helps. They prefer it to be towards mean. So there are ways where if that is the standard, right? You would always want to prefer it this way, but then it is not closer to this. It goes outside. You see this spread. So but mean is not the only thing which helps you with that. There are a lot of things: mean, mode, median. There are different statistical ways to get to understand the insight of the data, how the data is actually spread, right? Yeah. So let us assume if your data is not skewed, yeah, and everything is so good, your mean is equal to median. I don't know the notation of median. If this is equal to mode, if everything is everything is so same, it becomes a standard model. There is no data in the world which could attain like this, right? Only you have to make it. Natural phenomena may not support this, but then this is a very good scale for you to understand the data. Yeah, if it is of this nature, mean, mode, median. So but then this does not give you everything. Only mean, mode, median, when you are comparing it with the two different data sets, only this doesn't give you a perfect insight. Yeah, you could have two different data sets, okay, but then you could still have a same mean, right? So there you cannot rely. So these are your outliers, right? So let us assume this is your end, right? So there are outliers. So you cannot really rely on only mean to understand your data completely. So hence you would need a different measures. So what you will do, you will understand, oh, where is the starting point, where is this end point. So then you'll try to understand the range, right? When you want to compare the data sets, two data sets. So you will try to understand the range, and then, oh, range gives you a very good insight. But then, oh, I want to chunk this data. I want to break them into 4 parts, right? So you could actually make a quartile of this data or a percentile of this data. You want to chunk it and see. I will chunk this data and I want to see a different perspective. I will put different things. So I will see a perspective. So it is called quartile. So when you do a quartile, you can calculate an interquartile range, and you can assess your outliers, different outliers. Yeah. So your outliers actually helps you to bring that homogeneity in the data. That is why I initially made this point, right? The point of interest for us is we want that data to be more closer towards the mean. If two data sets have a same mean, but then they do not have, then we calculate the range, and then there is a disparity, right? There is a huge spread. Then we would want to measure that, chunk it, and then analyze the data further. Okay, so it doesn't stop here. There are different measures. So initially we try to understand how the data is spread. Is it spread centrally? It is called a central measure of you are measuring if the data is located central tendency. Later you're measuring the spread of the data, how it is spread. So range, quartile, percentile, they help you. And further you go, we want to see each of these points, how far are they from your mean, right? So that is where you get the variance. How are they varying from your mean? So how far are they from your mean? So you are comparing two similar data set, and another data set is following this. So you want to see whether this data set is better. You are at a task where you want to choose whether to go with this data set or this data set. We'll look at more examples in coming meetings, but then when these all are assessed together, that is when you can understand the data and make some conclusion out of it. So how it is. So then variance, and then you also calculate a standard deviation. Okay. So all this you do, but then what matters is in the ML world, statistics world, what matters is in the data engineering world, you are actually playing with the actual data, right? Whereas in the data engineering world, you give utmost importance to the visualization, right? Because you are going to deal with huge data, and it is humanly impossible to see the data. Hence, you would want to, for you to make the decisions, you would want to make a whole lot of data into the visualization. For example, we spoke on range, right? So range is something you can use a box and whisker plot, right? Where you can easily show the quartiles. So this is your Q1, Q2, Q3. This is your upper bound, and somewhere you will have a lower bound. So one visualization is actually speaking on your entire data set, right? Likewise, you could have a violin plot. Yeah, you could have a bar graphs, right? So heat map, many of them. So we will look at these visualization in coming days. But then this is why these are very important, and Python as a programming language has become so rich, because just with a one line of code you could achieve this visualization. You give the data set to it, and it gives you give the input as the data set to the function what Python libraries offer, and you could draw these easily. Yeah. So so this is a very high, what to say, broad explanation, right? How do we have to see the